Our next guest is the Astronomer Royal, who's joining us to answer your questions about the universe.
Yeah, you've got the message, yes. Good.
But first, Professor Martin Rees has a cup of tea and talks telescopes.
Okay.
Where is that?
Probably near to Paranal in Chile. But,
Yeah.
very close to where the VLT is.
Right, everybody happy? Okay, right, we are recording. Okay, Patrick?
Well, over the years of the Sky at Night, we've touched on dark matter and similar topics quite often. But when we called in for our questions, and over 1,000 came in for this programme, the most popular by far was cosmology. Right, can we have our first question, please?
Here it is from Alex Andrews of Oxford. Where exactly is the centre of the universe, and where is our solar system and galaxy in relation to it?
Yes. There's no place in our universe which is more central than any other place. This is, I guess, what's called the Copernican principle, which does seem to be obeyed by our universe. Every part seems to have had the same history as every other part.
Am I wrong here, Martin?
Yes.
When I'm asked that question, I say the Big Bang happened everywhere.
Well, indeed, it was one point, but that point has now had its aftermath everywhere, so we can't localise it at all.
No.
We're not in a central position.
One of the most counterintuitive things I think cosmologists say to me is that, so if the universe is infinite now, which it may well be, probably is, then it was infinite then. It was born infinite, wasn't it?
But with everything in one place.
All the space that's here now
Yes.
was there then.
In effect, because we don't quite know whether the universe is infinite or just huge but finite.
Yeah.
But it could still have been infinite even if it was really tiny.
Yeah.
Well, I maintain, I may be wrong here, that we're stuck either way. Either the universe is finite, or else it isn't. If it's finite, what's outside it? Say nothing, that's speaking of the question. If it's infinite, you've got to imagine something that goes on forever, and I personally can't do that.
I love it when astronomy gets so exhaustingly confusing like that. That's a
Question
wonderful thing. What is our universe expanding into?
Ah, yes.
Well, here again, the issue is our universe infinite or not? If it's finite, then it must sort of close up on itself. So the analogy people use is the surface of a sphere like that, where if you go on the sphere, you just go round and round, you don't get to an edge. And similarly, one dimension up. Many people think that the universe could be finite, but have no edge. So it would then be finite and it would expand, just as you could imagine that whole sphere being expanded.
An added complication is one of the things we're looking for at CERN on the speculative end is extra dimensions in the universe. Those are real. There are real theories that predict or suggest there may be extra dimensions, and that would mean that what we call our universe now is a sheet. Could be a sheet, a four-dimensional sheet floating around in a higher dimensional box, which
yes,
would...
well, that's right. The dimensions in string theory are normally thought to be very tightly wound up, so they only affect at small scales. But that may not be true. They may be detectable on the scales measured at CERN. But then, as you say, there is the idea that perhaps our universe is, as it were, alongside another. You can imagine this table and a parallel table up here, and ants crawling around on this table would think they're in a two-dimensional universe. They wouldn't be aware of another population. And likewise, one dimension up, there could be another universe just that far away from ours. But if that distance measured in some fourth spatial dimension, and we're imprisoned in our three, we wouldn't know about it.
One nice thing about that, it's still speculation, but this is a potential explanation for why gravity is weak compared to the other forces, which is something we'd like to try and understand. But if you allow gravity to leak off your universe and exist in these other dimensions, then you've explained why to us gravity appears weaker than the
Going
others.
into very deep water, so
It could be very shallow water, but in an extra dimension.
It's much more fun when we don't have the evidence, Patrick. We can speculate.
Well, the next one we have from Peter Burgess of Gloucester. How does gravity bend light if photons have no mass?
Well, photons have energy, not mass, but I think that's a kind of question that Newton would have worried about when he thought of gravity as the standard inverse square law, etc.
I mean, I think
my own definition of gravity is quite simple. Gravity is the force that gives mass weight.
Yes.
But I think it's the most incredible thing, the ultimate example of Einstein's theory, is that if I take this glass now, and drop it, everything falls at the same rate in a gravitational field. If I took a laser and fired it in that direction, if there was enough ground, it would hit the ground at the same time as the glass, because light falls at the same rate in a gravitational field as everything else.
Yeah.
The point is, though, that it goes 186,000 miles a second, so if this took a second to hit the ground, it would have missed the Earth. But if the Earth were big enough, it would hit the ground at the same time, because it travels through the same curved space.
And the fact that everything falls at the same speed is a natural consequence of Einstein's theory, whereas to Newton it was not obvious.
Fascinating. Right, John.
How are you doing, John? Are you okay?
It's fascinating.
This must be in Tom Baker's voice now.
Ah, yes, very well. Simon Hewitt of London, thank you for your perspicacity in asking this question. Will black holes eventually swallow up everything?
Well, Martin, will they?
Yes. We don't think so. They'll gradually swallow up the material around them, but most material won't fall in for two reasons. Either it's expanding away from them with the rest of the universe, or it's orbiting around them. And it won't be able readily to lose all its angular momentum. So it's pretty unlikely that everything will fall into black hole, but certainly more will. But then, of course, black holes don't live forever. According to an idea that Stephen Hawking worked out, black holes themselves gradually evaporate away. So in the very, very far future, there wouldn't even be any black holes.
We won't be here, and there won't be any sky at night. Right,
It might be a wonderful clean slate for another big bang to start everything up again.
That's right.
Absolutely.
Any more questions?
Well, one that's just occurred to me, this notion that if you travel fast enough beyond the speed of light, you will travel forward in time.
Can't go faster than the speed of light.
Well, you can't get there. You can't, because the closer you get, the harder it is to accelerate.
If you're massless, you'll go.
If you're
at the speed of
massless,
light.
yeah.
You can't go faster.
But I've heard this notion
If
that...
you reach the speed of light, your time stands still and your mass becomes infinite. Well, I haven't got that far. My mass is not infinite yet. Not quite. Jolly nearly, but not quite.
So the speed of light, 186,000 miles a second.
Yeah,
What
it's
is to
the
stop?
law. It's not just a good idea. That's
But
the
what
limit.
is to stop us when technology is
Well,
there to travel 186,001 miles per second?
It's not quite such a barrier as you might think, because although nothing can move faster than that, as seen by some observer at rest, because clocks run slow and aging occurs more slowly when you move fast, it is possible to get as far as you like in what's quite a short time as measured by your subjective clock, if you move close enough to the speed of light. So it's possible, if you go close to the speed of light, to get to the Andromeda galaxy and come back in what to you would seem quite a short time. But when you came back, at least 2 million years would have passed here on Earth.
Oh, the most wonderful example of that is for the light itself. So the distance, the light itself between us and the Andromeda galaxy, the time difference is zero. The distance is zero. Everywhere.
Well, yes, quite so. I'm rather stunned. What about you, John? Are you stunned too? I haven't any more questions.
Completely and wonderfully. And
Any more questions for us?
lightsabers, as seen in Star Wars. Lightsabers, as seen in Star Wars.
That's an engineering problem, John. Yeah, you're asking the wrong people.
Well, that was a marvellous discussion, and I hope everyone understood it and is now absolutely clear as to what it was all about. Martin, thank you so much. It's been a great honour to have you with us.